Hello, in this video we're going to have a look at the loci of equidistant points. So, fancy title, equidistant, it means same distance. So equi for equal, distant for distance. So equidistant just means same distance. And there's a couple of options we need to look at. The first one here, we've got 2 points, and we're going to be looking for the set of points, my loci, set of points that are equidistant, same distance away from A and B. So 2 options. First option, we're either going to get 2 points. The second option we'll have a look at later, where we've got 2 lines, and we're looking for a set of points at the same distance away from both lines. But we're going to start with this one. I've got 2 points. Sometimes there might be trees, there might be lampposts, there might be rocks in the middle of a field. All sorts of possibilities for what those points represent. I'm going to call them trees. I've got tree A and tree B. And I want the set of points that are the same distance from both trees. Well, I'm going to start off by drawing a line between my 2 trees. So my trees are just about 7 centimetres apart. So if I were to measure 3.5 centimetres, which is there, that point is 3.5 centimetres away from A, and it's 3.5 centimetres away from B, so it's equidistant from A and B. It's the same distance away from A as it is from B. So that's on my locus. It's one point to my locus of points, equidistant from A and B. And what I want to do then is I want to walk away from this point, and I'm going to draw a line on. I'm going to just mark it on. So if I were to walk away along that line, hopefully we can see that I'm staying roughly the same distance away from B as I am from A. So if I've got my pencil for my angle, if this angle, let's exaggerate it a little bit, is smaller than this angle here, I'm going to start getting closer to B than I am to A. Similarly, if I drew my line a little bit more like this, then this angle's bigger than this one, and I'm going to start getting close to my tree A and my tree B. So the only way that I can stay the same distance away from both of them is if I'm walking at 90 degrees from my line AB. So this needs to be a right angle. Well, what have we actually drawn? We've got 2 points, A and B. We've got a midpoint, so we've bisected A and B, and we've drawn a perpendicular. Just to be clear, not only goes above, but it also needs to come below my line as well. So all of the points along this line are going to be the same distance away from A as they are from B. Just want us to have a little think about what we did when we constructed our perpendicular bisectors. We took our compass, we put it on A, and we drew an arc. So all of those arcs, all of the points on that arc, are my compass is set at 6 centimetres, so they're all 6 centimetres away from A. And when I move my compass to B, and I haven't changed the setting of my compass, so it's still 6 centimetres, and I draw another arc, the point where those 2 arcs cross here is on this arc, so it's 6 centimetres away from this point, and it's also on this arc, so it's also 6 centimetres away from this point here. So this point is equidistant. It's the same distance from A as it is from B. So this line here is on my perpendicular bisector. We did the same thing. We did another arc on the bottom and drew a line here. So they're all 6 centimetres away from B. And we put the compass on A and draw another arc. All those points are 6 centimetres away from A. So that point must be the same distance from A as it is from B. So when I drew my line, remember I didn't measure this accurately, I didn't measure the angle, I just drew it roughly at 90 degrees. But if I connect up these 2 points here, then I've got an accurate perpendicular bisector. So I want to get rid of, this was my sketch. I've got an accurate perpendicular bisector. All of the points along this line are going to be equidistant. If I change my compass setting away from 6, I'd get two other arcs that would cross here and here. All of these points same distance away. So we use the fact that the points on the perpendicular bisector were equidistant to draw that perpendicular bisector in the first place. So I've got 2 points, and I want the set of equidistant points. I'm looking for the perpendicular bisector of the line that connects them. Right, second example. This time we are looking at 2 line segments that connect. In this case I've got line segment AB and AC. They're often hedges or walls, or it might be a wall in a very odd shaped room. Sometimes we've got other sides in as well, so this might be a field, and I've got 4 sides, 4 hedges on my field. But I'm interested in the set of points that's the same distance from line AB, so I've drawn it more heavily, than so same distance from AB as they are from AC. First of all, what do I mean by the distance of a point from a line? Because that's a bit weird, isn't it? So if I've got a line and I've got a point here, well, it sort of just depends how I connect up to my line, doesn't it? So if I take a point here, it's quite a short distance. If I pick a point here on my wall, that's quite a long distance. It's one of the areas in maths that were not very clear. If I talk about the distance of that point from a straight line, I'm interested in the shortest distance, and that's going to be when this is a right angle. So the first task in the lesson was to have a look at drawing perpendiculars from a line to a point. The reason we do that is because that's described as the distance from that point from this line. Right, so let's go back to our field and our 2 hedges. What have we got? I'm looking for the set of points that are the same distance from this hedge than this hedge here. Or if I stood in the corner here at A, then I'm the same distance, nothing, because I can touch both AB and I can touch AC. So my distance away from both those lines is 0. So that point is equidistant. It's on my locus of points. And I think you can see, if I were to go in a straight line somewhere along here, or I don't think I've drawn that very well, but never mind, it might prove my point a little bit. If I was to head in a straight line, I'm trying to stay the same distance away from this line as I am away from this line here. Now, if this angle, and I think mine is, this one here, is a bit bigger than this one, let's exaggerate it a little bit more, then I'm going to get closer to this hedge than I am to this hedge. If this angle was like this, so this is much smaller than this angle, then I'm going to get closer to this hedge than this hedge. So the only way that I can stay the same distance from this line and this line is if these 2 angles here are the same. So let's mark them on. This angle has to be exactly the same as this angle here. Let's put those 2 lines on saying these are the same angle. Well, what is that? Well, I've got 2 lines here, and I've drawn a line that cuts the angle in half. So this is an angle bisector. So one of the reasons a couple of lessons ago, getting quite a bit of practice at drawing both perpendicular bisectors and angle bisectors, is that they're really important for us in loci. So if I've got 2 points, 2 trees or whatever they are, then, let's move that down a little bit, then I'm looking for my perpendicular bisector. So all the points are at the same distance, equidistant from 2 points. I'm looking for a perpendicular bisector. And if I'm looking for the set of points that's the same distance from 2 straight lines, then I'm looking for the line that bisects the angle bisector. So it's going to be one or the other. If you've got 2 points, you're looking for the perpendicular bisector. If you've got 2 lines, you're looking for the angle bisector, and that's going to give you the locus of points that are the same distance away from both lines. Okay, your turn to get some practice. Follow the instructions in the document and have fun.